professor, physician, epidemiologist. I am Dr. Sri Banerjee. Hi, I am Dr. Sri Banerjee, and in this video I'll be quickly going over what a p-value is. Now for starters, I provided this video in the form of a concept and a question. So I started off by providing p-value and then providing the concept in the form of a question. So if you look at the important parts of this concept, one part of it is that you're assuming that the null is true. So given that the null is true, what is the probability of observing a more extreme statistic? So this could be the mean, right? So that is the most common type of example that is used in statistics to illustrate a p-value. So just keep this in mind, that you're actually assuming that the null hypothesis is true, and from that perspective, what is the probability of having a more extreme form? And that is where you set alpha at. And I'm going to explain this a little bit more, but let me go over this figure first. So here is a normal distribution curve, which you should be familiar with. And so you can see at the center there is typically the mean. And then the extreme values that I'm referring to, those can be seen in the purple regions. So there's another curve that we can draw, which can designate more of the alternative hypothesis region. And I'm going to make that a little bit more clear as we move forward. But imagine that this purple line is the actual test, the actual critical test statistic. So that critical test statistic, anything more extreme than this critical value, is considered to be significant. So let's take a look here. So there's two more color coding that emerged, and so one is kind of the magenta sort of color, and then on the right is green. So one that the beta is actually the type 2 error, the probability for type 2 error, and the alpha is the probability for type 1 error. And I'm going to go into a little bit more detail about that. So beta in the magenta color can be considered the probability of accepting the null when it actually was not true. And so you ended up accepting the null, and in fact it was in the territory of the alternative hypothesis. And you can clearly see that. Let me use a marker here, a laser pointer, and you can clearly see this, that the alternative hypothesis territory here is in here, and so this is where you're accepting the null when it wasn't true. So what's happening on the right? Let's take a look. So here you're actually you're rejecting the null, and as you can see, the rejection of the null is taking place because there's a supposedly a value that is more extreme than the null hypothesis. So you rejected the null, but it was actually true. So the green area is considered alpha, and this is rejection of the null when it was actually true. So another value that I want you to be familiar with is power, or 1 minus beta. So beta is the region that is right here, and anything to the right, any arrow to the right is 1 minus beta. So if you think about what that 1 minus beta region is, this is where you're deciding to reject the null hypothesis. Basically, power is what numbers of values do you need to be able to sufficiently and with certainty be able to reject the null hypothesis. And so these are the types of things that you conceptually want to be focusing on when you go through a step-by-step fashion of listing your research question, listing your null hypothesis, listing your alternative hypothesis, and then identifying the proper alpha level that you've selected, and then going forward and providing the test statistic and the interpretation from the p-value if it is actually considered less than alpha. So these are the steps that you would take using this as a theoretical guiding framework. So now you're not really in each scenario uh, you're not numerically calculating any sort of value, but conceptually you're understanding this. So I hope this figure, this drawing, provides you with some details. In the next segment, I'll go through a real life example that shows step by step how to complete this in a systematic manner. Okay, so here is my workspace for SAS Studio. Here are some functions that you can be using within your data set. And as I have shown previously, you can actually do a lot nowadays in SAS without having to use any sort of syntactical sort of code. And so I want to show the utility of this feature, the further utility, and also some of the neat sort of shortcuts that are possible as a result of these features. So let's get started here. Today's focus, of course, is looking for a relationship between two continuous variables. So before we start thinking about, what is it that we're trying to run, let's think about when we have two continuous variables, what's the first statistical test that comes to mind when you're thinking about two continuous variables? If you said Pearson correlation or something along the lines of correlation coefficient, then you were correct. So one important sort of functionality is this correlation analysis. It's the fifth menu down from statistic. When you do double click on it, there should be a middle panel that appears. And we already have a data set that is designated here. And let's make sure that this is properly designated. And so if we look and make sure that this is a data set that is properly designated from a file, and it in fact isn't. There's no error. If previously, remember, it was showing an error message. So now we can go in and look and select each variable and make sure that we have, when you're doing this, you want to make sure that you actually have a continuous variable. When you're first learning this, one challenge that you may face is that you'll select a variable initially that really doesn't really sufficiently satisfy the requirements of a continuous variable. So sometimes people will select gender, which is not a continuous variable. C-reactive protein and inflammatory biomarker, this is in fact a continuous variable. So I will select that. And then the other continuous variable, there are multiple variables that you can select from, but one that is very convenient and important to be thinking about is age. And so thinking about now that you have selected the variables, thinking about what you want to be looking for, this is what we are after now. So let's take a look at methods. Use non-missing values for pairs of variables makes sense, right? So What are the display statistics? There is default statistics, and you can keep this as default, but I would recommend that you have selected statistics so that you do want to make sure that not only the correlations are displayed, but the p-values as well. And then if you do, and what I want you to do is try to take note of how the syntax on the right changes and see uh, in the syntax there's proc core, which is a very famous, proc core is a famous sort of uh, procedure, and then Pearson. See, and you can see. I mean, you can read this data set on your own. You can read this syntax on your own and try to practice. See if you can actually write your own program with a different set of variables. So what you can do is instead of writing lbxcrp, you can replace this with another variable and see how that changes your results. So try to provide that, and then let's see with the results if we have anything that is in the output and if there's anything that we can interpret. And lo and behold, we have a um, significant row. The row is designated at 0.17. So what is interesting about the Pearson R is that not only is it a test statistic, but unlike other test statistics, it actually gives you the effect size within that number. So if you do use Cohen's convention or some sort of effect size convention, then you'll find that this has a small effect. However, what is important to note, it is statistically significant. So yes, the answer is that there is a statistically significant relationship between age and C-reactive protein, and it is in the positive direction, which means that as age increases, so does C-reactive protein and inflammation. And so this is actually an original, can be an original study that can be written up into a full scholarly peer-reviewed journal article. So this is an example of how you can quickly take a robust data set. This is again using National Health and Nutrition Examination Survey, and come up with some very uh, important findings that can lead you to better articulation and meaning from the study that you're trying to understand. I hope this video has helped in not only understanding some conceptual aspects of p-value, but also understanding the correlation coefficient statistical test. Thank you for listening.